Hi everyone, I hope you all are doing good and welcome to another video on a very interesting topic, which is data modeling and how this data modeling is actually beneficial if you're working as a business analyst or a data analyst. But in today's video, we will look into certain aspects of why data modeling is an important skill for business analysis. Okay. And we will also look at different sort of data formats that we deal with um, in the in the payment systems, or for that matter, any other domain. But particularly, we will keep payments um, as a reference because obviously we talk about payments on this particular channel. Why is it that this is important? This is an important skill for business analysts. So if you're coming in from a data engineering background, if you're coming in from a data architecture background, then obviously these things are not new to you. You understand these aspects. But why is it that somebody who's more from a functional background is actually expected to know these things? Maybe not as in depth as in a data engineer would, but at least he understands what is happening. So there are some points that I mentioned here, and again, these are the points that I feel that I have seen in the projects that I have been associated in the past. So that's what I have put out there as my experience. So understanding how the data is structured is extremely critical to understand the ever-changing business requirements. You see, we are talking about agile ways of working these days in all the projects around us, right? And the reason is that the requirements changed very often because there is some scenario that gets changed. But all I'm trying to say is that the requirements would evolve. What if all of a sudden you see a peak volume during the Christmas sales? Is your database ready to handle that kind of a peak volume? So those are the kind of things that we need to we need to think. It puts you in a better position to talk with the business as well as with the architects and the developers. So if you understand how the data is modeled, how the data is structured, then it puts you in that position where you can actually put your point forward and say, you know what, I come from a domain background, I come from payments, I understand the domain side of it, but I think if you put this particular field in this particular object rather than here, then it makes more sense. Helping in debugging the issues during message-based communications. If you're working in, say, projects where you have to go through some messaging logs, some failures you need to deal with, you need to replay the messages. There are some messages which have failed and they are going into a dead letter queue, and you need to replay those messages. Understanding these different message formats, right? And we will talk about the message formats in the later part of the video. But understanding this and looking at it from a data modeling perspective will again put you in a better position to handle those support escalations. Then it puts you in a position where you start visually understanding the data, and that's very important. When you start looking into the data as not just data, but then something that has an intrinsic value to it, sales data, for example, right? And I'm looking at the credit card swiping information. I'm looking at the transaction that have happened in this particular geography for the last 12 months. And I see that there is a particular age group which is not using the card as much as I wanted to. So why is that so? So now then, when you start looking into the tables, when you start looking into the data, you look at it from that perspective. And then obviously you're driving more insights and for analytical purposes, and that's the whole intent of doing all of this. So that's where I feel that if you come from a functional background or if you come from a business analysis background, it's highly critical that you have that sort of an awareness about what data modeling is, what are the different kind of data structures, what are the different kind of data file formats that are available today. So there is an important terminology here that you would again hear on and off. So NoSQL data modeling is something that you would hear quite often, and especially with event-based data. So what I mean by event-based data is that let's say, for example, there is a particular situation where they're dealing with the transactions, or you're dealing with, say, for example, disputed transactions, or so these are all event-based information, and these are all going to be flowing into your system through events. Industry as a whole, they identified some challenges with the relational databases. Relational databases work very well for OLTP sort of use cases where you want to make sure that there are say 5,000 transactions happening in a second, and you can handle all of that, and you can process them, and you can store them. But relational databases are typically in a very normalized structure. What I mean by normalized is that you don't want to have redundant information. So you basically break the tables in such a way that there is a joining key between one table to the other. Like for example, customer ID could be a joining key. And then you say that, okay, this is my table and I have the customer information in this table, customer's name, customer's address. If for some reason I want to know what was the transaction that this customer did, I will go to the transactions table, wherein there would be a column called as customer ID. And I will say that, okay, give me the details for this particular customer. And I will pass that ID over there. And then I can have all the customer details from this table and the transactions details from the other table, and I can join that information. And that's typically what we have been doing for quite many years. But over the past few years, what has happened is that we identified that this is a very costly operation if you want to use this data for analytical purposes, for example, because you have to rely on joins. And as soon as you start using joins in your SQLs quite extensively, they are going to be very, very performance intensive operations on your database. So what we do is we come up with new ways to structure the data in such a way that we can we eliminate these joins, and that's what we do in NoSQL data modeling. We try to model the data in such a way that we don't really need to fire a select SQL per se, but you can still query the data. And one important thing, guys, you have to remember is that it's not always the case that an RDBMS system is not good for you. There are certain scenarios where RDBMS systems may be the right fit for you. And even the RDBMS systems are also catching up. So there are a lot of different RDBMS systems these days which are highly efficient, and you can even go for that if that is the use case that you're looking for. So it's not a thumb rule that you should always go for a NoSQL modeled data only for your requirements. It's really something that is a use case dependent thing. One of the important things of NoSQL data modeling is because it handles the schema evolution very well. What I mean is, if tomorrow you want to change the structure of your data because of some business scenario changes, any event that triggers the change in your data structure could be because of two possible reasons. One, which is primarily the reason most of the times, is the functional requirement changes or the business scenario changes, and the business comes in and says that I want to add these more entities also in the data. Or there could be a technical challenge which has been identified, wherein it actually prompts you to take some corrective action, and therefore you need to do that through maybe making some changes in the schema. Whatever the case is, but the NoSQL data modeling helps you to do these things in a better way. Okay, so far so good. We understood about NoSQL modeling. We talked about relational modeling. We talked about joins and all of that stuff. But how easy or difficult is to still retrieve this information? Okay, so let's take a look at it from a different perspective altogether. So now we are bringing in third perspective, and very soon you will understand about this as well. Now look at this picture here. This is a picture of a shelf, a bookshelf. There are multiple books you can see over here, and it looks fine, yeah. So it's more like a relational table per se, if you try to relate, and everything has been put in different shelves, different rows, and it's all looking good. Now what if I want to pick up all the books of a particular label, maybe the books that have a gray binding, say for example. Okay, so now if I were to do that exercise, I would need to browse through each and every shelf here. So there is a gray binding book over there, in the second shelf over there, in the third shelf over there, fourth shelf. Oh my God, this is going to be a tedious exercise for me. I have to go through so many different shelves, identify all of those, take them out. What if somebody said that, give me a count of all of these books? So it's going to be a tedious exercise for me, and obviously, right, it's something that you would want to avoid. What if there was a more simple solution or a more streamlined solution where this could be done in a fraction of a second? So this is what we do in row-based storage, OLTP systems, as we talked about. Okay, now let's look at a contrasting picture over here. On the right hand side there is another picture. Okay, the same books. What I did is I took all of those books, and because I have a back problem, I don't want to bend down to the lowermost shelf to identify all of those books of a given color. What I have done over here is that the lazy part of my brain said that, why don't you organize these books in columns? And so you don't really need to worry about scanning through each and every shelf and hurting your back. you can actually go to the shelf again, or to these racks again, and say that, okay, I am looking at this particular column, and I know that these are the books kept over there. So like, for example, this particular column here, right? I know all of those books with the gray binding are kept here. I don't now really need to look. Now it's very easy for me to count. If I need to run an aggregation, it's very easy for me. I just need to look at that column and say that, okay, I don't care about all the other different columns. I just care about this particular column. I got that column. So that is what we do in column-based storage. Okay, so this is what is called as columnar databases. And again, we are only looking at it from a business analysis standpoint. So all that you need to understand is that columnar databases have evolved because of the requirement of looking into a particular value and then doing some aggregation, some operations on that particular column itself. And why do we need to scan the entire database? Okay, so that was the entire sort of a rationale of looking at a column based storage. So again, some of these new age databases, BigQuery, if you talk about GCP, Redshift, if you talk about AWS, they would handle the data in that particular fashion. Okay, so now let's look at another important question over here, which is, does one size fit all? Okay, so you can see there is a team that is doing some brainstorming over here. There is a data engineer, there is a data analyst, or a visualization expert, somebody who is experienced into some business intelligence tools. There is a data architect who is busy doing some brainstorming, and then there is a product manager standing on the right hand side who's also looking at this entire discussion. So now you enter the room, business analyst, and you basically are a domain oriented person. You understand the domain in and out, but then this is a different set of people here, right? So you have got a data engineer, analyst, architect, technical guys over here, and then there is a product manager. So what typically happens is that there will be a lot of discussions around some of the questions which are very important. Come up with the right structure for the data. What is the kind of read speed that I'm looking for, and the write speed? So what I mean is, how efficiently should I be able to write the data into the system or the database, and how efficiently I should be able to retrieve or read that information if I need, for example, doing some reporting or analytical purposes. What if I want to run all of this data and process it in chunks? Like you have 10 gigabytes of data, and you say that I don't want to process this 10 gigabytes of data serially, but I would rather want to chop them down into chunks of 2 gigabytes or 1 gigabyte each, and then I would like to process them parallelly. That will be a faster execution, of course, right? So do you really need that kind of an operation? What if the schema changes happen? So is the data, or is the problem that we're talking about a problem which typically would warrant a change in the schema anytime soon? And how frequently are those schema changes happening, right? Is there something that happens less frequently, more frequently? All of those kind of things is again an important question. And again, there could be some important inputs which are organization specific, right? So for example, there could be some organizations which are very, very sensitive towards security and governance. So they may have some particular inputs from that perspective, particularly payments, for example, right? We do a lot of focus on PCI governance and things like that. If you haven't watched the video on PCI, you can just pause the video here and you can go to the playlist of payments, and you can watch that video where I talked extensively about what the role of PCI is. But the point here is that there are multiple questions, and this is the kind of brainstorming discussions that happen over these questions, which will help you to come up with the right modeling strategy for your data requirements. Okay, so there are some data formats that I have listed down over here. Now what we will do is, we will stop the video here and we will go to our Miro board, and we will look into how these data formats come into play. We will particularly focus on the top 4 that you see over there, which is the CSV, the relational database, the XML, and the JSON. And the reason being that when you come from a business analysis background, then these are the 4 which are kind of critical for you, because these are human readable formats. So if there's some analysis that needs to go into the data side of it, then you're probably looking at maybe something like that. The ones that are there at the lower half, which is like protobuf, avro, orc, and parquet, these are all formats which are all like binary. They're not very user friendly when it comes to reading the information directly by a human, but then they're highly efficient. And that's the whole purpose of having these mentioned over here in this slide. And the last two there at the bottom that you see, the ORC and the Parquet, they are all column based storage. Remember we talked about the column based storage a couple of minutes back. So that's basically the two of them over there. So let's take a pause here and let's go to the Miro board and look into the details over here. Okay, so now let's look at the board here, and we will look at a very basic example of how the modeling would look like for different systems. Okay, so we'll look into the relational and the non-relational, both of them, and then we will try to draw some parallels over there and maybe try to do some comparison as well and see how they fare. Okay, so we are doing this because obviously, right, there is huge data volume, and we had this traditional relational way of handling the data modeling initially. So let's look at that first, at what used to happen. Let's say, for example, again, we're talking about the payments data over here, and there is a transactional data that you want to deal with. Now you can see here there are three different tables. Okay, the first table will have the information about the transaction itself, like what is the transaction ID, the amount, and what was the card number, or PAN as we call it, permanent account number, for that particular transaction. And then in the second table, we have some details about the customer. So we have a customer ID, we have a PAN for that customer, the name and the address where the customer stays. And then also we have some information about transaction itself. Okay, so for example, what is the transaction type, whether it was a sale or a return, and whether we should be debiting the customer or crediting the customer, depending upon sale or return. And there are three different tables, okay, that will handle this information. And there are three transactions as you can see over here, belonging to three different customers. So far it's all looking like a typical relational model. And as you can see over here, right, you can see that I can use something like a transaction ID if I want to join, say for example, the first table and the third table. Okay, so that's the kind of an example that I'm trying to give over here. I can probably add a customer ID in my first table and then use that as a key, in my second table, okay, as a foreign key in my second table, which is about the customer details, and say that, okay, I can pick up all of my details. So it really depends on how I am looking at this information. Now, this was all working well for us, as in from an OLTP standpoint, but not for OLAP systems, okay, because of joins and all of that theory that I just explained to you a few minutes back. And obviously changing the schema was a real pain. What if I wanted to add another column in this data? That was something that was a nightmare, because it's not easy, and you may need to drop the table and then alter the table and add those values, and then again put the data back in those tables, and all of that thing was quite painful. So storing the data and then retrieving them is a real pain, and which is where we are looking at this second way of looking at this information, which is the NoSQL, or not only SQL, as many people call it as. So here what we will look at is the same example, which we had looked from a relational standpoint. We'll look into it from a non-relational standpoint now. It's like I want to get rid of the joins. So what I have done is I have one parent object over here, which is called as transaction ID. And then this will hold all of my information. So I don't really need to join tables now. I have a field called as PAN over here, and within PAN I will have the customer ID, the customer name, the customer address, age. I have transaction details as another object, which will hold things like transaction amount, transaction type, and the debit and credit indicator, depending upon whether it's a debit or a credit for the customer. And then what if tomorrow I want to add another amount called settlement amount, say for example? Well, it's just easy then for me, because this could be an array type for me. And within an array, I can have more than one different kind of transaction amounts, or really amounts. What if I wanted to add another object? So this allows me to extend it and say, for example, tomorrow, if I wanted to identify whether this particular transaction is a foreign transaction or is a domestic transaction, and I wanted to have a flag for it. Well, this is easy for me to do now, because I just need to add a field in the schema, and then, so I don't really need to drop a table and do all of that cumbersome tasks, which I needed to do in the relational side. So this is good for our OLAP processing. Storage and retrieval is easy. It's ideal for event-based data. and cloud loves it too. Like I mentioned, different cloud providers are now having this kind of a strategy for you. So everybody's embracing this. And then we will look at the columnar side here, right? So where I said that um, I will hold the information in different columns. So transaction ID would be one column for me. Age will be another column. Age of the customer. Amount will be another column, and then transaction date. Now, if I were to answer a question that comes into me from my marketing team because they are not very happy with the performance of this particular credit card, and they say that give me all the total transactions and amount spent by the customers along with their age on 14th of February. And they noticed that they were expecting a huge jump in the card swipes on Valentine's Day, but that didn't happen. And they were surprised. They were expecting that there would be good sales on Valentine's Day. So they wanted to know what's happening over there. They wanted to look at that information from an age perspective. So how is it that the card is doing in a 30 to 35 years age versus a 35 to 40 years age, and things like that. So as people get older, do they start celebrating less, or what is happening there? So they will have this kind of question, and then it will typically come to your data team. You could be a data analyst, business analyst, and then they would ask you that can you get me that information? So now if you have your data structured in a columnar way, it's very easy now. I don't really need to care about all the other columns. There are other columns. There could be a column, for example, PAN. There could be a column, for example, something else. All that I need is a count of the total number of transactions that have happened, and I will need to group them by age. That's it, and I'm done. So I can have 2 columns, 3 columns, depending upon what I'm interested in, and then I don't need to look into all the other different columns, and then I can go to that particular chunk. Okay, so that's where I was talking about distributed file processing, where we divide that entire data. Now, if assume that this whole column was 20 gigabytes. Okay, now this could be that 20 gigabytes to read everything together in one single shot would be again a bit of a challenge. So what I would do is I would divide this into chunks. I would say that one chunk of 1 gigabyte each or 2 gigabytes each, and let's have it in different nodes. So basically there'll be a data cluster, and then you would have different nodes which will have each of these gigabyte or 2 gigabytes per node kind of a storage. And then if I'm looking at one particular kind of a chunk, there would be some keys, of course, that will do this. So I will say that, okay, I'm looking at this particular chunk, maybe for only, maybe that distribution is done on the basis of the timestamp or the date. So I will say that, okay, I am not interested in any other days on the Feb. So let me not put the pain on the table and the storage by going through the entire month of Feb. I'm just looking at 14th of Feb. So I'll specifically pick up that particular chunk, which I am interested in, which is for 14th of Feb. Okay, so I've also given some examples here of different databases that if you're interested to read about, go to the internet and you can read, HBase, Cassandra, MariaDB, Redshift, BigQuery, Snowflake, very popular Snowflake, these days. It's a complete cloud data platform for you. So we will not go into the details of all of those things. It was just to give you an overview so that when you move into projects, if you are freshers and you are coming into the industry for the first time, or if you are a business analyst and you are working in an IT project, then this helps you to at least get that familiarity and that awareness. And then it gives you that base, and then you can read a lot about all of these different topics and you can build over it. But the idea is to give you a base here. Okay, so that's about the columnar database. And let's go back to our example here, right? So we looked into that tabular structure. We understand the columnar storage also now. What if that same relational data, which I had shown you here, right, in this particular view, what if I wanted to handle this in a NoSQL structured way? So it's very easy now. I showed you that the tree-based structure here, but let's make it a little bit more specific. If it was CSV, I could just simply write a single line. This is more like a row, right? So this is not typically what we are looking at, but I have just, for the sake of example, I put that here because CSV is also a very important source. Specifically, you're dealing with, if you're dealing with data science, analytics, you're looking at writing Python code, and then you're reading some data set and doing some operations. So this is something that typically you will find a lot. So that's the reason of mentioning it over here. That this is very simple, right? I've just put everything here in one single line: transaction ID, amount, card number, name of the customer, address, sale, and then so on and so forth. It will all follow. Very simple, straightforward way of looking at the information. Okay, and then let's look at this other way. And these two are the important ones that I wanted to talk about, which is XML and JSON. So XML is extensible markup language, and JSON is your JavaScript object notation. Okay, so if you look into this structure, right, and try to relate with the tree structure, you will find some analogy over there. So I have a main object called as transaction detail, then I have transaction ID, and within transaction ID I have everything about that particular transaction. So basically you can see that there is a main object, then there is a child object, and then there is a sub-child object. So it's like a hierarchical order here that we are trying to maintain, and that hierarchical order is what helps us to get rid of the joins. And if I have some information that I know might repeat, for example, transaction ID, something that will repeat, then I'll have another object for transaction ID equals to 2. So that's more like an array sort of a structure. Not exactly an array, but typically similar to that. And the same thing, if I look into the JSON structure here, right, you can see exactly the same thing, but different ways of representing the same information. Now, there are some striking differences if you observe these two. Let me zoom it a little bit more. So, okay, now I think it's better. So if you see here, right, there are some striking differences between these two formats. Put down in the comment section and let me know what you think are those striking differences that you can see. Pause the video here, look for a couple of minutes, understand what we're trying to do here. It's the same sort of data that we are trying to represent in two different formats. Look into these two different formats and put down in the comments and let me know what is the difference that you see. Okay. So now let's talk about those differences. So if you see here, exactly the same information. I can see some braces and some square brackets. So this is basically a Java script object notation way of representing the information, JSON way of representing the information. But the important bit here is that you see in the XML structure, the tag name is getting repeated. So for example, when I'm saying transaction ID, I'm using transaction ID here and then I'm closing it here. Indicator, I'm writing it here and then I'm closing it here. Whereas here, I'm just using it only once, indicator, and that's it. And I'm just using this curly braces and then comma to basically take care of the syntactical part of it. Now, what happens is, this is one transaction. Imagine if we do this for thousands and millions of transactions. The space that it occupies is less, on the right-hand side here, as compared to this. Obviously, because you have this name being repeated. So this will occupy some space in the database. So as compared between these two, XML and JSON would be obviously space efficient for you. Okay. And again, if you talk about event-based data, you would find a JSON quite extensively being used. Now, another important or interesting exercise that you can do is you can use some samples online, some XML samples, and there are multiple different websites which will do the conversion for you. So if you find it difficult for the first time, let's say if you're not very comfortable with the syntax of it, then what you can do is you can take an example of an XML format and put it into that website, into that the input box, and then press the button. It will do the conversion for you automatically, and you can see how that conversion happens. But I would strongly recommend that you start practicing it yourself and then see what mistakes are you making. Typically, the mistakes will happen in where should I close this bracket so that the entire object gets closed and things like that. So that comes with a little bit of practice. So that's not a problem at all. Okay. Now we talked about three different formats here: CSV, XML, JSON. Now all these three formats are used for data serialization, which is basically when you are trying to move the data, flow the data, and in the form of smaller bits rather than one single complex object. So which one do you prefer, right? CSV, XML, JSON, they all have their own pros and cons. You have to tell me in the comment section. Okay, so please, if you find it worth it, then do let me know which, according to you, in your experience, if you've already worked in these three formats, is the one that you prefer and why. These are all non-binary. These are human readable and very, very important for business analysts because this is human readable, and therefore from an analytical perspective, it's important. Okay, so guys, we have looked into all of these formats, but at least the first four in detail. And we have also talked about Protobuf, Avro, ORC, Parquet. You can read a little bit about these formats yourself. But yeah, the first four are kind of a little bit important. Okay, so with that, we come to an end to this video, and I hope you liked this video. This was a little bit of a different video as compared to the regular domain-related videos that I post about payments. But I'm sure you will find this video very, very helpful in your projects. You would come across one of these formats, and it's always helpful to understand the differences between these formats and in which situation I should use one format versus the other. So I hope this whole overview of why data modeling is done and why is it relevant for business analysts to know about data modeling is something that you found useful. And I will take your leave now, but I'll see you all back again sometime soon with another interesting video. So until then, please take care of yourselves. Goodbye.